In this section, you'll learn about the Cisco troubleshooting methodology. So that's the Cisco official methodology or framework for how you should carry out troubleshooting. We're not really going to go too deep into troubleshooting examples because I'll be doing that for all of the different functions and features on your Cisco routers and switches throughout the other sections. So we're just going to really cover the methodology here. I'll also talk about some of the more common troubleshooting commands to test connectivity, and we'll have a little example in the lab as well. So this is the official Cisco troubleshooting methodology diagram, and this is the recommended way by Cisco to work through troubleshooting a problem. Now, to be honest, as you get more experienced, you'll be able to troubleshoot just naturally without having to think about it using a diagram like this. But this is quite useful if you're new to networking, to lay out in a logical fashion about the steps that you can follow to figure out what's causing a problem. So up at the top, the first thing to do is to define a problem. So clearly specify exactly what the problem is. Once you've done that, you then move into gathering information. So find out information about the problem. For example, let's say that we've got a connectivity problem. We would check to see if we can ping from the source to the destination. If not, we would find out, is it just affecting that one host or is it affecting other hosts in the same area? If it's only affecting that one host, the problem is probably with that host. If it's affecting everybody on that IP subnet, then it's probably not a problem at the host level, it's probably something in between the host and the destination. So we would then find out other information like asking, has anything changed recently? If it was working before. So if it was working before and now it's not, find out what's changed, and that's probably going to tell you what the problem is. Next thing to do is to analyze that information. So ask all of the relevant questions, not just asking questions of people, but also using show and debug commands on your devices to get the information. And then analyze that information and look for clues about what's causing the problem. You can then move on to eliminating potential causes. So for example, if we're troubleshooting that connectivity issue from a source to a destination, and there's several routers between the source to the destination, if we check the first hop router and the configuration all looks good there, we can eliminate that as the cause and then check the next hop router along the path. Next thing to do is to propose a hypothesis. So taking all the information into account, you will determine what appears to be the most likely cause of the issue. Then you test the hypothesis where you actually put the commands in or do the thing that would fix that problem. Then if the problem is fixed, you've solved the problem, we're down at the bottom now, last thing to do is to document the solution. Now, this is something that's not fun to do, but it's important to do it. And if you do get into the habit of doing it, you'll thank me later, because sooner rather than later, you will run into a problem that somebody else ran into the exact same problem before. If you've got proper documentation in place in your organization, it should be very easy and quick for you to find the solution because somebody's documented that problem and the solution. If you're not doing any documentation, well, if it took an hour to fix it the first time, it's going to take you an hour to fix it this time as well. Whereas if you had documentation, maybe it's only going to take a few minutes. Also, this is not just for other people that may be facing the same problem as you afterwards. It's for yourself too. Maybe you run into the same problem, but a year down the line, and you can't remember exactly what the issue was, but if you've got the documentation there, you'll be able to quickly look it up and quickly find a solution. Okay, so that's a standard way to troubleshoot from start to the end. But you'll notice there are some other arrows and arrows going in different directions here as well. So sometimes we can move straight from the gather information stage straight to propose hypothesis. If this is a problem that you've seen before and you're pretty confident it's the same thing again, you don't have to spend time gathering additional information. Just put in your solution that you think is going to work and see if it works or not. Also, often we can move back to an earlier stage if we don't manage to fix a problem the way that we thought we were going to. Okay, so that is the Cisco troubleshooting methodology. For troubleshooting methods, again, experience is really going to help you here. Sometimes it makes sense to do a top-down approach, sometimes a bottom-up approach, and sometimes divide and conquer. And what I'm talking about here is it relates to the OSI stack. Some problems, it just makes more logical sense to start off at the application layer and troubleshoot it moving down through the layers. Other times, it's easier to do it the other way around, where you start troubleshooting at the physical layer and then move your way up through the layers. And other times, again, you can divide and conquer. For example, if you see a problem like a connectivity problem, you've seen similar problems with this before, and it's always been caused by an issue at the network layer, you could go straight to the network layer and start troubleshooting there. Based on what you find, you could then move up or down through the OSI stack. And remember, as we said before, having a good understanding of how IP networking works, as we covered in the life of the packet section, and also how the OSI model works, is going to really help you understand what's going on. And when you understand what's going on, that makes it easier to troubleshoot problems. Some methods we can use in our troubleshooting. The first one here, we can compare configurations. If you're in an organization, often you will use templates for configuring your routers and switches. An existing organization, you've already got existing routers and switches there, so rather than doing a new configuration from scratch, you'll do it based on a template. So if you are doing this and there's a problem, you think it's on a particular router, you can compare it with another router that should have a similar configuration and look for any differences there. Maybe you've got a typo or maybe a missing command. By comparing it with a known good configuration, this can help you find the problem more quickly. For connectivity issues, what we're usually going to do is trace the path. And as a network engineer, a lot of your day-to-day job is going to be troubleshooting connectivity problems. So you will do this very, very often. The best way to troubleshoot connectivity problems and tracing the path is start off at the source and work your way towards the destination. In fact, on a slide coming up, we'll cover some of the commands that we're going to use here. The last one mentioned here is swap out components. If you think that you've narrowed the problem down to a particular device, but you can't see a configuration error on there, a way you can confirm it is by swapping it out with some known good hardware. Like the problem might be down at the physical level or something like that, or maybe it's just something you're missing. So, for example, a really simple one would be a cable. If you think it's possibly a cable issue because all the configuration appears okay, but there's some kind of physical layer problem, just swap out the cable and see if that fixes it. Okay, so I just mentioned about some of the common commands that we will use to troubleshoot connectivity. Really super common command to use is ping. That checks connectivity between two devices. When you send out a ping, it uses ICMP and it sends a packet from the source to the destination. The destination will then send a ping reply back again. So ping verifies two-way connectivity. If you've got connectivity from the source to the destination, but the return path from the destination back to the source isn't working, then the ping will not work either. So this verifies two-way connectivity between a source and a destination. And this is often one of the first commands that we'll use if we've got what looks to be a network connectivity issue. The next command we'll probably use after a ping, if a ping fails, is a trace route. If you've got multiple routers between the source and the destination, what you can do is you can troubleshoot it from source to destination. So say we've got routers R1, R2, R3, and R4. You could check R1 first. If it all looks good, you move on to R2, then on to R3, and so on. Well, a trace route can sometimes speed this up a bit. A trace route does a ping hop by hop from the source to the destination, and it will often indicate which router along the path has got the problem. And finally, we can use Telnet. Telnet is normally used for managing your network infrastructure devices like your routers and switches. We can use that to get onto a command line on the device. But another thing that it can be used for is checking to see if a port is open on a destination. Rather than using Telnet to the default port of 23, we could, for example, Telnet to port 80. That will verify if port 80 is open and receiving communications on the destination. Okay, so next up, let's have a look at this in the lab. And I'll do that using this topology here in the next lecture. This lecture follows on from the Cisco troubleshooting methodology, and here we're going to have a look at how to do some connectivity troubleshooting using the commands ping, traceroute, and telnet. So the scenario we have here is we've got the network topology over on the right, and there is a user on a PC which is behind the R1 router, and he's complained that DNS isn't working. And in the example, the DNS server is our R3 router. Okay, so first thing to do, real world, whenever a user reports a problem, is don't believe them, check it first. I have spent hours troubleshooting problems that turned out not even to be a problem at all. The thing was actually working, it was just that the user was making a mistake, maybe a typo or something like that. So let's verify if DNS is working or not. So on R1, I'm going to ping R3 by its hostname. So I'll enter the command ping R3. And I can see that my domain server is 10.10.30.1, which is R3, so that's good. But it says unrecognized host or address or protocol not running. So we do have an issue here. DNS is not working. So if we suspected this was an IP connectivity issue, the next thing that we would do is do a ping from the source to the destination. So in R1, I'm going to ping 10.10.30.1. So I'll ping it by its IP address. This takes DNS out of the equation. And I can see that the ping is failing, it is unreachable. So I've got some kind of connectivity issue between R1 and R3. Now what I could do now is I could go hop by hop checking to see where the problem is. So I could check that R1 has got connectivity to R2, then R2 has got connectivity to R3, and so on. But a command I can use that will save a bit of time sometimes is traceroute. So I'm going to traceroute to 10.10.30.1. Now, what the traceroute command does is it does a ping, but it sends the ping with a time to live value of 1 and then 2 and then 3 and then so on. So because the time to live is set to a low value, if a router sees a packet and the time to live gets down to 0, then the router will drop that packet. It's a loop prevention mechanism. And we can leverage that with traceroute by sending the first ping with a time to live of 1. So it will get to the first router. Then it will send a time to live of 2. It will get to the second router. Then a TTL of 3 and so on. So what this does is it maps out the path from the source to the destination from end to end. And if there is a break in the connectivity somewhere along that path, then the trace route should get as far as that router. So it helps us identify which router the problem is on. So let's try the trace route. And we can see that the first hop, it's getting to R2 on 10.10.10.2, and then that's as far as it got. So the final router it got to was R2, so the problem is most likely there. So let's just jump straight onto R2 and see what we can see on there. Okay, so here I am on R2. On R2, I'm going to ping R3 on 10.10.30.1, and this ping I can see is failing. So the next thing I'm going to do is R2 does not have an interface directly connected to the 10.10.30 network, so it would need a route to get there. Don't worry about routing too much now because we're going to cover that in a later section. But for now, I can check the routing table with the show IP route command. So I do this and I can see that yes, there is no route to 10.10.30. So I'm going to fix that. So I'll enter the command config t to get to global configuration, and the command to enter a static route is IP route, then the network I want to get to, which is 10.10.30.0. The subnet mask is 255.255.255.0, and the next hop address to get there, which I need to have an interface that's on the same subnet, is 10.10.20.1 on R3. So I'll try that and then end to get back to the enable prompt, and I'll ping 10.10.30.1 again, and I can see that the ping is successful. So if I now go back onto R1, then hopefully the ping will work okay from here too. So here's me back on R1. I'll ping 10.10.30.1, and the ping is successful now, so I've fixed my connectivity problem. Okay, so that was a demonstration of how to use ping and traceroute. The other command we can use here is telnet. So ping and traceroute will troubleshoot layer 3 problems. You can use telnet to help with layer 4 and above problems. What telnet you can do with it is you can telnet to a particular port. So from R1, I'm going to telnet to 10.10.30.1, and I'm going to telnet to port 53, which is the DNS port, and this should tell me if DNS is running on R3 or not. And there I can see that port 53 is open, so R3 is running DNS. So that looks good. Just to double check this, I'll check DNS is working. I will ping R3 by its hostname, and I can see that it resolved it to 10.10.30.1, and the ping worked. When I did the telnet, if it did not see the port as being open, then that would indicate that the service is not running on that particular destination. Okay, that was the basics of IP connectivity troubleshooting, and that wraps up this section. See you in the next one.